Okay, we're doing section 13.1 today from our Algebra and Trigonometry book, Intro to Periodic Functions. A periodic function is a function that kind of repeats itself, kind of like a pattern across the x-axis or the domain. Kind of the paragraph talked about dependent variables and all of that. It's really just referring to the function when you graph it, repeats itself as you go, left and right on the graph. And so these exercises that you're going to be doing um, will describe something that it wants you to sketch a reasonable graph, meaning that there's not, specific X and Y points that you're going to be graphing, but to kind of just do like, hey, what would a graph look like if I was graphing these points? And to tell if the graph is periodic or not, right? So we'll take a look at this first one here. Number one says the depth of the water at the beach depends on the time of day due to the motion of tides. Okay, so if we're going to graph that, do a reasonable graph. Okay, we'll just do our XY axis here, origin. Okay, so it says the height of the tide over time, and we know the tides go kind of up and down over time, and so time usually, actually for the vast majority of the time, you're going to have time on your x-axis, so that's going to be how time passes from 0 onward, and then the y-axis then is going to be our dependent variable, which is the height of the tide. So we could start wherever. We know that the tide um, let's see here. It's probably never going to go into the negative, but we can kind of just, kind of imagine that, uh, you know, 0 is going to be just kind of the lowest it can go. And so we might draw something like this. Okay. And it keeps on going. So down to the x-axis here, that's the lowest the tide will go. This is the highest the tide will go. Lowest and highest, and keeps on going for forever. As long as the moon's going around the Earth, we're going to have tides. And so this is our reasonable graph. We can also kind of continue it on this way if we wanted to. Okay. If we're going to go back in time, we'll get the same sort of shape. And that's the key there. The same sort of shape means that it's a periodic function. It's going to repeat itself as it goes along the x-axis. Okay, so in this case, number one here, the height of the tides is periodic. Okay, and the reason it's called periodic because each of the times that it kind of repeats itself, so from here to here, okay, the highest point to highest point, that's going to repeat every period. Okay, period is kind of the thing that happens again and again and again, so it's a periodic function. Okay. Now, if you might graph something else, and we'll take a look at some of the other examples here. Um, Let's see here. The temperature of a cup of coffee depends on how long it has been since the coffee was poured. Okay. So that's not going to be a periodic, and the reason is because the temperature just decreases and then it's cold. That's going to stay there. Okay, so if we're going to do another graph, okay, over time, that's our x-axis. We'll just say, time over here. And we got the y-axis, our origin. And, at the beginning, when you first pour your coffee, it's going to be pretty hot up here, whatever it is, I don't know how hot it's going to be. But over time, it's going to decrease. And, it might be decreasing kind of like this or like this. Okay, but either way, it's going to be going down, right? It's going to be going down the y-axis, the temperature as time moves on. Okay, it's never going to go back up because it's just saying it's cooling down. The question saying it's not like on the stove or it's going to heat up again. And if you did that, if you did, heat it up and then cool down, heat it up, then it would be periodic. But in this case, it's just cooling down and that's it, right? So this is not periodic, okay, because it doesn't repeat itself. All right, and that's all for this section.